So looking at the very first one on page 45, we're looking back, representing decimals using these base 10 models. Remember, a rod is considered 1/10. A little bitty square is considered 1/100, and then a big block or a big square is considered 1 whole. So if I'm writing the decimal to represent the first model, how would I write this decimal number? 0 point what? How many tenths do I have? Yes, I have 6 tenths and I have 2 hundredths, so it would be 62 hundredths. So fix it if you have something different or if you did something different. And then the one next to it is going to be 0.26 hundredths. So which one has more? Which one's bigger?
26.
62 hundredths is larger or greater than 26 hundredths. There are more pieces, okay? For us right brain people, us visual people, seeing pictures can help us understand why certain decimals are bigger. Okay, the next one, how many tenths do I have?
0.8.
I have 8 tenths. Okay, what about on the right side? How much is that? 8 hundredths. Which one has more? The 8 tenths does. Each little individual square, this is just one of these. So 8 hundredths is like only having 8 of these squares and one of these tenths rods. So having 8 whole tenths rods is way more than just 8 tiny little hundredths. Okay?
Where it says 0.08, how would that be that? I thought it would be 0.8.
Up here it tells us that it's 100th, that one of these squares is 100th.
Oh.
Okay, down at the bottom, our last one. Remember, the whole square is representing one whole, so it's going to be 1 point something. What do I write? 3, because it's 3 tenths. I have 0 hundredths. Is it totally wrong if I put a 0 in the hundredths place? No, it's not, because I have 0 hundredths. So you could read it as 1 30 hundredths or just 1 3 tenths. I can leave the hundredths off altogether because I have none. Okay, the next one would look like 1.33 because I have 3 tenths and then I have 1 2 3 hundredths. So which one has more? Which one's bigger? 1 33 hundredths. Okay, what we're going to be doing today is a little sampling right down here where it says looking ahead. We're using patterns that I notice in the models above to compare the decimals using less than, greater than, or equal to. So looking at the very first problem here, I have, how do I read this number? Can somebody raise their hand? Okay, how do I read that number?
0 and 625 thousandths.
Very good, 625 thousandths. So this would be 267 thousandths. Which one has more thousandths? Fala. Yeah, so 625 thousandths is greater than 267 thousandths. Think about that in number form. 625, 267. Which number is bigger? The 625. There's going to be more of the little thousandths pieces in 625 thousandths. Okay, what about 800 thousandths compared to 8 tenths? Kingston. Equal. Okay, here's where it gets a little tricky. So if I put 2 zeros and now they're both written to the thousandths, you can see that they are the same amount. Okay, don't forget those zeros. I could put 1,000 zeros after a decimal number. it doesn't change how much that number is worth. The only thing it changes is how I say what? How I say the words. Okay, that's it. That's the only thing that changes. All right. 1 and 338 thousandths compares how to 1 and 334 thousandths? Is it greater than, less than, or equal to? Ace? Greater than. Okay. There is a method that I like to use when we're comparing decimals and ordering decimals. Because it's the first time that I've ever taught this curriculum, I'm not sure if they're going to go over it. So I will introduce it and I will show you if it doesn't end here. Okay. So let's turn to the first page and let's look at example 1. Okay, we have this completed example up here, so you have everything done for you. You're given a place value chart. Are you starting to get used to these place value charts? I hope so. We've seen them a lot. Okay, our little cat, that's a cat, or a dog, cat, I think it's a cat. Okay, the little cat friend says, think about this. 2 and 4 tenths is equal to 2 and 40 hundredths, which is equal to 2 and 400 thousandths. You can place zeros and blank spaces to help you. I like to call those zeros zero the hero. Okay, any zeros that I use to help me are called zero the hero. So if I ever say that, that's where that's coming from. Okay, so 0 is less than 5. So if I'm comparing both of these two numbers, when I'm going one place at a time, okay, notice these are the same digits. These are the same digits. I can't tell which one's greater until I get to the thousandths column. Now I can see that 0 is less than 5. So that means that 2 and 4 tenths is less than 2 and 405 thousandths. I'm going one space at a time until I find a difference. Whichever one is smaller, that's going to be the overall smaller number. Okay, we're going to see a few examples. Sometimes you'll have it on a number line. A number line is super helpful because you can actually see the numbers that are further to the left are closer to 0. And then the further right you go, what happens to your numbers? As you travel to the right on a number line, your numbers are getting what? Bigger. Notice how they're getting bigger. They're increasing as I continue going this direction. So on a number line, 1 and 58 hundredths is to the left of this number. So that means that it is automatically less than the other number. Does that help visually? When you move left, my numbers are getting what? Smaller. Okay, so they're going to be less than. All right, let's look at example 1. We are given a place value chart. So what we're going to do, this is what I call stacking numbers. So when I was saying a very helpful tool that I typically use when teaching comparing and ordering is stacking. So we're going to stack our decimal numbers together. When you stack, you want to make sure you line up your decimals. So you're going to start by writing 9.063. And then you're going to stack the other one directly underneath it, 9.067. Your decimals are in line so that your ones digits are in line, so that your hundredths digits are in line, and your thousandths digits are in line. Okay, now that I have this, let me see if I can make something real quick. Okay. So now that I have everything stacked, how do I just move this guy? There we go. I'm going to start with my ones place. Can I tell in my ones place which number is bigger?
No.
What about my tenths place?
No.
What about my hundredths place?
No.
Here, can I tell which one's bigger?
Yes.
Okay, so which number is bigger? The 7 is bigger. Okay, so that means that 9 and 67 thousandths overall is going to be greater than the other. So what symbol will I use? Will I use 9 and 63 thousandths is less than this number? This is greater than this number, or they are the same? Less than. Remember, when you put in your symbols, You want it to open up to the bigger number. Some of y'all probably learned Pac-Man or alligator when you were younger. The mouth of the alligator wants to eat the bigger number. Okay? All right, on a number line, 2 and 415 thousandths is compared to 2 and 405 thousandths. Well, I don't have any of those numbers on my number line. So what can I do? What can I do to help me on this? Both of these have 3 digits after the decimal, but the numbers on this number line do not. So what can I do to help me? Anybody have an idea? Add zeros. Good. I heard somebody say it. Add zeros. Okay. So we're going to add zeros so that every number is written to the thousandths place. So now instead of having 2.4, I have 2.400. So it reads 2 and 400 thousandths. I'm going to add a zero here to give me a third digit. How is this number read? How do I read this number?
2 and 41,000.
Close. Not 41. 4. Good. 2 and 410 thousandths. And then how is this number read over here if I add a 0? 2 and
42,000.
try again. 2 and 420 thousandths. Okay. So now, can I figure out where these numbers go here and here? These two numbers. Can I figure out where they would go on this number line? Think about it for a second. If this is 400 and this is 410, that means I'd have to have 401, 402, 403, 404, 405, 406, 400. So can one of these numbers fit in this section? Which one would go here? The 2 and 405 thousandths. Okay. And then this number over here, where would it go? It's 415 thousandths. Ben?
I would go between the 2 and 410 thousandths and 2 and 420.
Right in the middle. Very good, Ben. So 2 and 415 thousandths is where this one would go. Okay, so now on a number line, can I visually see which one is greater? So how am I going to draw my symbol? 2 and 415 thousandths is less than, greater than, or equal to? Greater than. So the mouth is open up to the bigger number. Okay, now you have just plain numbers. We had stacking our decimals together. We have a number line on number 2. But for 3 through 5, I'm just given plain numbers. You can still use those strategies if you want to. If you are a visual person, stack your numbers. It's easy to do. So if I do, I want to make sure my decimals are lined up. So I have 4 and 6 thousandths, and I'm comparing it to 4 and 61 hundredths. Remember, this only has 2 digits. So what could I always put after that number to fill in a gap? I can use 0 the hero to fill in that gap. So now it's a little easier for me to compare those numbers. So which one looks bigger now?
4 and 61 hundredths.
Right. This number, 4 and 61 hundredths, is actually bigger. Here's where students a lot of times get confused. They see this and they're like, oh, it looks bigger. It's got 4 digits. This only has 3 digits, so this one must be bigger. I see it all the time. Students get confused all the time because they see a bigger number and they're not paying attention to the decimal. But what this is actually saying is 6 thousandths compared to 610 thousandths. So this number, even though it has the least amount of digits, it is technically bigger. So I have 6 tenths here, and I have 0 tenths in this number. And then I have 1 hundredth here, and I have 0 hundredths here. And if I read it and I write this number to the thousandths place, 610 is bigger than just 6. Good question. Okay, the next one, again, I have 2 digits after the decimal versus 3 digits after the decimal. So I can put a 0 after, and what do I notice about these numbers? They're equal. And then number 5, I can stack them. 0, 4, they almost look the same, but what do you notice? If I stack them up, I can't tell from the ones place, but I can tell in the tenths place which one is bigger. So the 4 tenths is more than having 0 tenths, which means that overall this number on the left is going to be greater than, less than, or equal to? Greater than. Good. Okay, how are we feeling so far? Okay, let's keep going. I want you in your table to try number 6. You're still using comparing symbols. This time, though, it gives you one of them in word form. So write it in standard form so that you can compare them. Okay, so if you took those word forms and you wrote them in standard form, like a regular number, you would have 41.6 on number 6. Okay, looking at this, do I have a greater number on the left side or the right side? This is 41 what? How do I read this? Thousandths. 41 thousandths. This is 41 and 6 tenths. Which one's greater? 41 and 6 tenths. Good. Number 7 says 7 thousandths. It looks like this number here. Okay, what if I write this number to thousandths and I put 2 zeros? Then I'm really comparing 7 thousandths to how many thousandths? 700 thousandths. Which one's more? The right side's actually more. 700 thousandths is actually a whole lot more than just 7 teeny tiny thousandths. Okay, this is where plugging in 0 the hero is super, super helpful. Okay, complete the number to make the statement true. I want to make a number that is less than 10 and 311 thousandths. So right now I have 10. Okay, these digits are the same, 10. The tenths digit is the same, and the thousandths digit is the same. So I need to put a digit in between the 3 and the 1 that is less than, because of this symbol right here, the 1 in this place. So what number is less than 1? 0. This has to be 0. It can only be 0. Nothing else will work. Nothing else is smaller than 1 that I could plug in there. Okay, number 9, I have 28 and 60 hundredths is less than 28 and 60 something. It's got to be less than. What could I put, Jeb? I could put a 5. Would that work? What else could I put? I could put a 1. Could I put something else?
Yeah, you could put any number above 0.
I can put any number greater than 0. So I could put 1, I could put 2, I could put 3, 4, 5, 6, 7, 8, or 9. Why do any of those numbers work? Why would any of those work? Yes.
Because they all fit and they're greater than 0.
Because they're all greater than 0. That's the important thing to notice. Okay, every single one of those digits, 1 through 9, is greater than 0. Because I want the number on the left here to be smaller. So if I plug in a 0 in the thousandths place, that means any number in the thousandths place to the right has to be greater than 0. Okay, order the decimals from least to greatest. Oh my goodness, that's a lot of numbers. So here's where stacking our numbers becomes super helpful. So off to the side, I'm going to write all of those numbers down, starting with this one. So I have 321 decimal point 499. If I write, you write. If I do, you do. We are now on number 10. I'm going to color code the next one. I have 325 decimal point 499. And then I'm going to color code the last one. I have 321 decimal point 489. Okay. I just want this. There we go. Like I just want to move this. Okay, so starting with my largest place. Can I tell which number is the biggest from the largest place?
No.
What about the next?
No.
What about the next?
Yes.
Okay, so I know which one is definitely not the least. Okay, my middle number is going to be listed where? I'm ordering them least to greatest, so at the end, good. Okay, so I can go ahead and copy that middle number down at the very end because it is the biggest number, and I can already tell that just by the ones place. So I'm going to copy down 325.499. It's the largest number. Okay, if I keep going, I'm now comparing my tenths digits. Can I tell? Now I'm only looking at the blue and the purple at this point because I've already identified that the red number is the biggest. So based on the tenths digit, can I tell if the blue or the purple's smaller? What about the hundredths place? Which one's smaller? Yep, the purple number is smaller. So I'm going to list that one first. So 321 and 489 thousandths is less than 321 and 499 thousandths, which is less than 325 and 499 thousandths. Okay, y'all try number 11 and do that same thing. Guys, I know you don't have a little rectangle digitally to move around, but what do you have in your hand that you can use to cover up? A pencil. Or a finger, okay? Use anything you have at your desk to cover it up and move one place at a time. Try number 11 with your table. All right, so did you guys stack your numbers? You should. Okay. Use your finger or your pencil to move one place at a time. Can I tell, based on my ones digit, which one is going to be the smallest?
No.
No. Moving over to the tenths. Can I tell which one is the smallest?
Yes.
Which one?
Middle.
The middle number, the blue number that I color-coded up here. So I'm going to go ahead and list 9 and 64 hundredths in that first blank. 9 and 64 hundredths. Okay, so based on that, I go one more space over. Now, why is that 0 green?
Because there's nothing.
Because there wasn't anything there. I put that there. I put 0 the hero there so that everything has 2 digits after the decimal. Now, which one's the next smallest? Is 0 or 8 going to go next?
0.
The 9.70 will go next. So when I list it, I'm going to put my original number, which is 9 and 7 tenths. And then my very last number, which is 9 and 78 hundredths. Okay. Oh boy.
Oh boy.
This next one.
Don't put your seatbelts, everybody.
No, I don't know. All right, number 12. Match the decimal with its position on the number line. Then order the decimals from least to greatest. Match them, then order them. Okay, so I have 1/10 plus 9 hundredths. It's expanded notation and fraction notation. So what does that give me total? 1900ths. So if I add this together, this is going to be 1900ths as a decimal. Okay. Notice on my number line, I have 0.1 and 0.2. Well, I already have hundredths here, so let's go ahead and just add a 0 and another 0 so that I'm looking at I'm looking at 10 hundredths and 20 hundredths. Okay, where would 19 hundredths go on that number line? The very last one. So this one goes here. All right, the next one is 130 thousandths. 130 thousandths. How do I make that out of 100? Jeb?
Divide it by 10.
I can divide it by 10. And if I do that, I'm essentially just taking away these zeros. So now it's 13 hundredths. Where would 13 hundredths fall on this number line? Which dot?
Second dot.
The second dot. It goes right here. Okay, what if I have, now these are different over here in my pink box. How can I make sure that I have 100 over here? What could I do to this fraction to make them out of 100? If I want to add a 0 to make it 100, what do I have to also do to the top? Add a 0. So 20 hundredths minus 2 hundredths. What's 20 minus 2?
18.
This is going to be 18 hundredths. So where does this one fall? Which dot? The first or the third dot? The third dot right here. Which means that the purple one, 11 hundredths, should go way over here. Okay, so now I can list them in order from least to greatest. Which one goes first?
The 11.
And how do I write it as a decimal? 0.11 because it told me decimals. So 0.11 is less than, which is the next one? 13 hundredths. Which is less than 18 hundredths, which is less than 19 hundredths. If I write, you write. If I do, you do. If I have it, you have it. Super important that you make sure you copy everything that I have. Okay. This last part is a puzzle.
We're doing it?
We are going to skip it and come back to it. And I'm going to let you do it at the end.
If we don't want to do it, can we wait, do we have to do it?
Yes, you need to do this one. So you guys can complete the puzzle until it's time to go. Okay, we're almost done. All right, here we are stacking our numbers again. And this is that method where you take something like your finger or your pencil and you go one digit at a time. We're putting them least to greatest. So it says you stand on a leg for 2 and 75 minutes. Your friend stands on one leg for 2 minutes, and your cousin stands on one leg for 2 and 25 minutes. Order those times from least to greatest. So the first thing that I want to do is I want to stack my numbers. So I'm going to write all of those times. I'm going to color code again so that you guys can see them. I have 2 and 75 hundredths. If I write, you write. I have 2 minutes. Does 2 go here?
No.
Does it go here?
Yeah.
Okay, so then what should I fill in since it's just a number 2? Zeros. Okay, and then I also have 2 and 25 hundredths minutes. Okay, so now I've got these pieces. Again. Oh my goodness. There we go. Okay, can I tell which one's the smallest just from the largest place value? Okay, what about here? Which one goes first? Least to greatest, middle. Okay, blue. So 2 is less than, and then which one is the next least? Uh-huh. So 2 and 25 hundredths, and then the next would be 2 and 75 hundredths. You can tell the entire answer just based on the hundredths digit. That is keeping you from doing your work today. Thank you. Okay, number 15. 3 wheelchair racers competed in a 400-meter race. The times in seconds were 57 and 69 hundredths, 57 and 63 hundredths, and 56 and 99 hundredths. Y'all try this one with your group. So stack them all, write those numbers off to the side, stack them up, and order them. So y'all talk about it. Okay, so if you stacked your numbers, looking at the very first digit, the 5 and the 10s place, can I tell which one is the least?
Yes.
No, I can't.
No.
Can I tell by looking at the ones digit? Okay, so which one's going to be written first? 56 and 99 hundredths. Okay, I still can't tell between the red and the blue ones that I've color coded. So I'm going to look at the 10th place. Between the red and the blue, can I tell which one goes next?
No.
Not until I get to the very last digit. Which one goes second? The blue. 57 and 63 hundredths. And then the last one should be 57 and 69 hundredths. Good. All right. Everybody with your groups, try this last one. Actually, try it by yourself. Try it by yourself without talking. And then check with your group mates. So we're going to try this very last one by ourselves and then check it.
I got something 26, and then 2, 3.79, and 75.6.
If you agree, tell the person that told you, me too, great job, and high five. Awesome. Okay, I need your attention in 5, 4, 3, please, 2, and 1. All right, so on this one, what did you guys get first? Tell me what you put first.
23 and 76 hundredths.
23 and 76 hundredths. If you're looking over here, I know automatically that the one that starts with a 7 should be last. So that one is 75.3. That one's the very last one, 75 and 3/10. Your second one in the middle should be 23 and 79 hundredths. All right, you guys can go back and do the puzzle with your group. That's the last thing we're going to do today.